Okay, today we are seeing the topic, it is matrices, and under that we are seeing the diagonalization of a matrix. Cayley Hamilton theorem. So the statement for the Cayley Hamilton theorem is every square matrix satisfy its own characteristic equation. Okay, so we'll see by the problem what is it, this statement, how that matrix will satisfy the characteristic equation. So first of all, we see the example now. Verify Cayley Hamilton theorem and hence find out the A inverse, and A is given to you. So we have to use the Cayley Hamilton theorem to get the inverse. So first of all, we just write down here the matrix as it is, and we will find out the characteristic equation for that given matrix. And we are having a one formula for that, getting the characteristic equation for the 3 by 3 matrix. And the formula is what? Lambda cube minus S1 lambda square plus S2 lambda minus determinant of A equals to 0. Now what is S1? S1 stands for the sum of the diagonal element. It is 1 plus 1 plus 1. It will be what it is? 3. Then S2 stands for the sum of minors of diagonal. Diagonal ke minors ka sum. So what will be the minor? Minor for this one will be leaving the column, leaving the row. Where left elements are here 1, 2, 2, 1. Just take a cross multiplication. It is 1 minus 3. 1 minus 3 is what it is? 1 minus 4. 1 minus 4 is minus 3. Now to find out the minor for this one, leaving the column, leaving the row, it is 1 minus, it is 16. That is minus 15. For this one, leaving this column and the row, then take a cross multiplication of remaining element, 1 minus 4. It is minus 3. So just take a sum of minors of diagonal element, that is S2. And now then calculate the determinant of A. Determinant for this you can calculate by calci. So minus 9 is there. Do the calculation. We have this one. It is lambda cube minus 3 lambda square. Then addition for this minus 21 lambda minus 9 equals to 0. And this is the characteristic equation we are having. Okay. And now what does this statement says? Every square matrix satisfy its own characteristic equation. We have obtained the characteristic equation. So this matrix A will satisfy this equation. What does it mean? I can replace the lambda by it is A. That means, so I am replacing the lambda by A. I have then here A cube minus 3A square minus 21A. I am replacing the lambda by A. Now here it is minus 9. It is a scalar equation we are having. It is a minus 9. But it is a matrix equation. तो आपको 9 को multiply करना पड़ेगा by identity matrix to make this equation as a matrix equation. And RHS part will be a big 0, which stands for the null matrix. Okay, so this way we convert this characteristic equation into a matrix equation by using Cayley Hamilton theorem. Cayley Hamilton theorem says that every square matrix satisfies its own characteristic equation. That means we can replace the lambda by A. Now we have to verify this equation. So for verification, I consider the LHS and will show it is equals to RHS. So I consider the LHS part. I calculate it is A cube matrix, then A square. A is already given to you, and I will take as a 3 by 3 matrix this 1 0 0 0 1 0 0 0 1. Now compute the calculation. We do the here addition and the subtraction of the matrices. 93 minus 3 into 21 minus 20 into 1 minus 9 into 1. This gives the first element for the matrix. 78 minus 3 into this 12 minus 21 into 2 minus 9 into 0. The second element. So likewise you have to calculate all the 9 elements calculations. And you will see then all the elements calculation will be it is what? 0. So we get a null matrix, and hence we can say that Cayley Hamilton theorem is get verified. So LHS part equals to it is RHS. So we have this Cayley Hamilton theorem which is verified. Now we have to use this Cayley Hamilton theorem to find out the inverse here. So we just write down the equation as it is, this equation. Now to get the inverse, I just multiply this complete equation by A inverse, because हमको A inverse निकालना है. Now if it is asked to in the examination find out A to the power minus 2. So I will multiply the complete equation by what is it? A to the power minus 2. But it is asked here find out the A to the power minus 1. So I am multiplying this complete equation by A to the power minus 1, that is A inverse. Now next, multiplying by the A inverse, we get this quantity. A inverse into A cube, A inverse into A square, A inverse into A inverse into it is I. Now A inverse into A cube, that will be A square by indices rule. This will be A inverse A square will be it is A. and A inverse into A, it is I, the definition of inverse. Okay, multiplication of A with inverse will be it is I, then A inverse into I will be it is just a A inverse, because when we multiply the identity matrix with any matrix, we have a same matrix then. So we have the A inverse. I take this to the RHS part, that will be the 9A inverse, and the remaining left is this one, this quantities. So we have a square, A, and as well as the I. Now compute this matrix calculation, and we are having this matrix then. Taking this 9 here, it will be 1 by 9 of this matrix, and that will be our required A inverse. Now here we can simplify this quantity once again further. So I divide this by the 3, I divide whole the quantity by 3. So 1 by 3 यहाँ से common निकाल के मैंने divide कर दिया हर एक quantity से. I get 1 by 3 of this matrix. So this is our reduced A inverse. This is also correct. This is also correct. You can stop the procedure up to this as well. Okay. So this way we get the inverse of a matrix by Cayley Hamilton theorem. Previously we have seen many methods. That is, we are having many methods to get the inverse. जैसे आपने देखा होगा, we have a Sylvester's theorem to find out the inverse. We have a Gauss method to find out the inverse. As a different method, a partition method is there, adjoint method is there. So this is the one more added here to find method is there to find out the inverse of a matrix. So this way we solve the example on Cayley Hamilton theorem. Okay, thank you. किसको डाउट है अभी भी?